Dear students, welcome to the knowledge series. This is the course on EC407 Computer Communications. Here I am going to discuss the module 1 with respect to EC407. You can see here the textbook mentioned data communication and networking, 4th editions by Barrows A400, Tata McGraw-Hill publications of 2006, a cryptography and network security by Barrows A400, 4th editions, Tata McGraw-Hill 2008 publications. These are the textbooks, followed by the reference books, Larry Peterson and Bruce S. Dave, Computer Networks, A System Approach, 4th editions, Elsevier India 2011, J.F. Kuros, Computer Network, A Top-Down Approach, featuring the Internet, 3rd editions, Pearson Educations 2010, S. Keshav, An Engineering Approach to Computer Networking, Pearson Education 2005, Achyut S. Godbole, Data Communication and Networking, 2nd editions, McGraw-Hill publications, New Delhi 2011. So in the module 1 we are going to cover the area with respect to the introductions to computer communications, transmissions mode, switches, various type of switchings, networks and its models. This we will be discussing in a various segments. So let us start with the module 1, the area with respect to the first introductions. As you can see the slide on computer communications, the term computer, it is an electronic device that accepts the inputs as input parameters and deliver the output depending upon the processing contents. Or in another word, we say that it's a device that accepts the input and give the desired results or informations as a single standalone device. Now that is a computer. When you talk about a communications, it is basically an exchange between the two parties or the two entities, the information that it exchange. So when we talk about electronic communications, electronic communication, it consists of telecommunications and data communications. When we talk about a telecommunication, tele means distance, a distance communications, and data is nothing but informations. So that is electronic communications. So when you talk about telecommunications, what are the things comes? We have a computer is there, we have a telephone is there, we have radio, televisions, mobiles, all these things is coming under the telecommunications. Now when you talk about data communications, what is the role of a data communication is nothing but to transfer the data or informations between the computers. So that is what we do in the case of data communications. Now when we talk about communications, automatically the next parameter is coming as transmissions. It has to transmit. So if you see here in these figures, there is a terminal computers shown, and on the other side a modem is shown. Modem means a modulator and a demodulator. It's a hardware device which used to convert the data into a suitable forms. Say if you are connecting in your home, you may be having a modem connected to your LAN cable. So from the LAN the signal comes, it will convert the signals into a appropriate forms so that the computer can able to perform and able to operate the internet connectivities. So that's why it transmits. There is a transmission line is there. There is a receiver line is there, and also there is a control line is there. So this is how the computer is trying to communicate. So when we go little below, you can see there is a figure with respect to a modem that is shown over there with respect to some bandwidth. Over the bandwidth your modem works. What the modem does is that whenever the analog signal is there, it will convert into a digital forms. So that is how the particular modem will do that particular activities. Now here there is another representation is there. In the computer communications there is a signals. We all say that in the nature the signal, everything is in the analog forms. So that analog signals, it has to first of all sample. So we do some sampling rates, and based on the sampling the signal, analog signal, is converted into a digital forms, and thereby this digital signal is being further appears in the computer sides. So suppose if you are taking a simple LAN phone is operates in the form of a analog operation. Suppose if you are having a the old form of a olden days, the rotating mechanisms for dialing systems, that type of phone, if it is analog forms, that is being connected to the modem, then that analog signal is being converted to digital form, and thereby the computer will able to recognize that particular information which is being passed through the cable across the transmissions line. So this is how this particular things work. Now there is another factor is that when we talk about computer communications, here also it is a terminology is that data communication. Now what the data communication is doing is that it is basically a process of transferring a data from a one point to another. Now when we talk about a one point to another, it may be transmitting from this point to this point, either by connecting a cable, or it will be transmitting from this point to this point in the wireless medium. So that's how it will able to transmit. So here you can see a data communication is interested in transfer of data, that is the informations, and the method of a transfer is nothing but whether we are using a particular wired media or a wireless media, that is how we will be able to transmit, and the preservations of a data during the transfer process. That means we try to see that the data which has been transmitted through this medium, the information is not changed or it is not altered because of the transmission error. So that's how we will try to preserve the informations related to that particular data, and that's how the data communications take place. Now there is something like rules and regulations are called protocol and standard in the data communication. We will be discussing this particular term, protocol and standard, in the later part. So when we talk about a protocol, is nothing but rules, and that rules should have some systematic approach. So that's a standard. So the rules and regulations are called the protocol and standards. The another area is that telecommunication. When we talk about telecommunications, the telecommunications as I shared is that it is a distance communication. So there will be a voice channel will be there, talking to someone on the phone using a voice channel. Maybe it is analog signal, and that signal it has to convert to digital forms, and thereby the data channel are dedicated lines for communicating the digitized voice and data. So in the data channel we will be sending this digitized form of a signal after converting through a analog to digital converter. The voice channel communication rate is 300, 1200 like this one, in the form of a bits per second. So here it is a 56 kbps, like that you are having a voice channel, voice communication rate is being shown, and the data channel typically transfer the transfer the informations or the rate for the data communication are 56 kbps up to 155 mbps. So if this channel has to carry forward, so automatically the data channel rate is being shown in this form. So thereby this voice channel will be automatically carried by this data channel. So when we try to see this one kbps or mbps, you should understand that it is a digital form of representations. Now coming to the next part, communication component. Now what exactly mean by communication component? If you try to see it, this particular bottom side of a figure, you can see that one here is a sender is there, here is a receiver is there. So source and host is being this is a terminal point is there, and the channel is nothing but a medium. A medium is being shown is there from a sender to receiver. So between this sender and the receiver there is something you cannot see, but we have used the terminology here, protocol and a standard. So a protocols is coming inside this, a protocol is coming inside this. So based on the protocol, the sender communicate with the receiver using a medium. So that's why a source, it is the transmitter of a data. You transmit the data. Examples, terminals, computers, mainframes, all these things is there. So you can able to send the informations. Medium may be wired medium or a wireless medium. So you are having a cable, a wired medium. Microwave, it's a radio signal, wireless medium. Fiber optics, it's a wired medium. Radio frequency, it's a wireless medium. Infrared wireless, all this thing is nothing but a medium through which our signal has to pass. So if you find the fiber optics, you will be having a very low loss. But when you talk about a microwave frequencies or a radio frequency, you will be finding a losses will be there. So all these particular challenges that computer or a data communications has to take into account for a proper data communications. That's why you are studying this particular course. The receiver of the data transmitter from the source, it will be receiving at the receiver end. For example, printer, terminals, mainframe, computer, all these things will be also coming. Because when you talk about a computer here, that means one computer will be communicating with the other computers. So that will be just like it is a sending from a sender to the receiver. So that is how this particular computer communications take place. So with this one, the further is protocols. As I have already stated, is that it is a set of rules that coordinates the exchange of informations between the sender and the receivers. So that is how this entire communication components work together. Now here another way it is being shown over here is the between the sender and the receiver is a DT to DC, medium is the again back to DC and then again back to DT forms. So this is the representations of the another form of computer communications, or the representations of the how the data is sending from the source to the receiver end. Now coming to the bottom side, as I shown here, is that message you are creating in the center side based on certain rules, and that rules is the creation of that message, and that message you transmit across the channel. At the receiver end, that same message is retrieved in the similar form. Say for example, you take an example like this one. You are sending a email. If the email is sending from the sender, it cannot be received by the WhatsApp, or if a WhatsApp message is sent, it has to receive by the WhatsApp at the other end. WhatsApp message will not be received by the email unless and until there is a proper configurations between the various applications. So in the same way is this particular form, the sender and the receiver is communicated. So in the digital, if the terminal end is able to transmit and the other receiving end, the terminal, if it is receiving, there should be a proper systematic entity should be defined. Based on whatever the entity is here, the same entity should also be there on the other side. So this is how the data communications take place. Now we will see the another segment about the characteristics of data communications. Now for effectiveness of a data communications, some of these components are considered as a fundamental characteristics for the effective communications. So let us see some of the communications with respect to the first is delivery. We want a very reliable delivery. So a system must deliver the data in a correct way or in a correct order to the appropriate destinations. That means if a device is sending a message, it should not go to some other destination. So a reliable delivery should be there. That is what we mean to with respect to the delivery. Accuracy. The system must deliver the data accurately. That means there should not be any alteration of the data once the data is being moved out of the source through the medium until it is retrieved at the receiver end. Timeliness. Timeliness means the data must be timely delivered by the systems without much lags. Otherwise what will happen, there will be a variation in the informations received at the receiver. Say for example, audio communications or a video transmissions, it should take place in a proper way between the sender and the receiver. Otherwise the real-time transmissions will not take place. Jitter. What is jitter is means that it represents the difference in the delay based on the informations that is being sent. We are sending in the data in the digital communications information in the form of a packet. So when this packet is being sent, there should not be a uneven delay. Otherwise what will happen, the quality of the information, particularly in the video case, it will get disturbed, and the quality of the signals will be not good. Now here there is another terms which is being mentioned, data communications ideal characteristics. So what are the ideal characteristic for a data communication? The very important is that we have to see that the data communication should be able to deliver the signals with a maximum energy. So from the transmitter to the receiver. That means electromagnetic signal should be maximum strength over which the signal should be able to transmit, and data when it is transmitting that particular signal, the cost of that particular energy for transmitting the signal should be low. Second content parameter is that channel over which the signal is being transmitted to the receiver, channel should not be much noisy, otherwise it will corrupt the message, and there should not be a restrictions between the transmitter and the receiver. See, particularly in the microwave communications, we say a line of sight. Line of sight means the transmitter and the receiver should view each other. If there is some obstacle object come in between, say building comes in between, then the proper signal transmission will not take place in the case of a microwave. So that's why there should not be any restriction between the transmitter and a receiver with respect to the distance. So this is one of the important components with respect to the characteristics of the data communications. Next comes transmissions mode. The data communications, when we say the communications between the two device, it should take place in a different modes. That is what we say data flow. Data flow is take place in a 3 modes. One is simplex mode, another is half duplex mode, and third is a full duplex mode. You can see here, this is a simplex mode, this is a mainframe, or you can think like it is a transmitter and this is a receiver, or you can take a mainframe and your computer systems that is a server and a systems. So this server is sending us message, that is a direction of data is shown, it is from this place to here. It goes from the sender to receiver. So in this case the communication is nothing but in the form of a one-way communication. That means if these systems can able to send a signal from this end to this end, but this signal I will not able to send a signal from this end to this end, then this form of a communication is termed as a simplex. Or in another word, we say that in the case of a simplex, the transmission is in the unidirectional. That means the information flow in one direction across the circuit, and there will not be any response from the other circuit to the sender circuit. That is, the receiver circuit will not able to send any response. So this type of a particular communication you can see in the case of a radio and televisions. In our home we receive the radio signals or a TV signals, that is a simplex form of a communication or a one-way communications. The next is a half duplex. You can see this one, there is one station here, direction of one signal is shown here, direction of another signal is shown here. So in this mode of transmissions, each communicating device or each stations can receive and can transmit informations, but not at the same time. That means when this is sending, this will patiently waiting for listening it. After that, when this is sending, this will be patiently waiting for listening that particular informations. So in this case, this is a two-way communications, but this one send the data at a time t1, then this one will be sending a data at a time t2. Now in the for example, like a walkie-talkie or a internet searching, we are using this form of a communications. And in particularly in the this half duplex form of a communications, what we are doing is that we will be occupying the complete capacity. Capacity means complete bandwidth of the signals in this particular case, because one time this is transmitting, one time this is transmitting. So you are occupying the entire capacity of the transmissions medium, transmission medium during the time of a transmissions. And it is possible that there will be a error in this particular case, and if there is a error is there, either the sender or the receiver will able to communicate it back that there is error in the transmissions. Then the whatever the information was transmitted, it will be resending it back again. So that is the case with respect to the half duplex mode. Now we come to the third case, that is nothing but our full duplex mode. In the full duplex mode, you can see this one is that there is a one station, but direction of a data flow take place in both directions, but there will not be any time difference. In this mode, the data can be transmitted in both the directions simultaneously. And full duplex you can compare as a two-way traffic or a two-way road, where the traffic will be flowing in both directions. So that is what we can see in the on a road. One side, like in the main road, we will see one direction for a one traffic, another direction for another traffic. But on the inside road, or the road which is not a main or a branch road, you will see that it is a bidirections. So that is what we see in the case of a full duplex conditions. So in the full duplex conditions, we will be using a mobile phone communications. The current mobile communication is nothing but the full duplex situations. Now in this mode of communication, nowadays even we are able to get the cable communications, which can be used for not only TV signal but also for the data communications also. Say those are nothing but the communications are coming under the full duplex modes. So this is one of the important area of the topic which normally appears in the exams. So data flow is take place in simplex, half duplex, full duplex. This is unidirectional, and it is a bidirectional case, that is a two-way communication. This is also two-way communications, but in this case two-way communications one at a time, but here both can communicate together. Now we try to see the transmissions mode methods. What is the what exactly this transmissions means? Transmissions mode, basically it refers to the communications of the information between the transmitter and the receivers. So that is a mechanism for transmitting the informations or the data. And it is also termed as a communications mode, just like we have seen earlier is nothing but the transmission mode. Here this is a communications mode of another form of representations. Now basically in this form of representations, it talks about the way the particular transmissions or the movement of the signal from the sender to the terminal should take place. So the classification of data transmissions, as you can see over here, it can be either in the form of a parallel or in the form of a serial. If it is a serial case, it can be either asynchronous, or it can be synchronous, or isochronous. So this is how the data transmissions is being represented. So this is also one of the important area. So here you can see that the transmissions of a binary data across a link can be accomplished in either parallel or a serial. That means any data transmission is taking place, you have to understand it is in the form of a bits. So that's why analog to digital converter should take place. That's what here it talks about, a binary data that is in the bit forms. In a parallel mode, multiple bits are sent together, and in the serial mode, one bit is sent serially. So that is how, based on the clock tick. We will see the figure in the subsequent slide. While there is only one way to send parallel data, there are three subclasses of a serial transmissions. That is what it is shown here as synchronous, and isochronous. Now let us see the parallel transmissions. Now here in the parallel transmission, the transmissions of a binary data is being linked between the sender and the receivers. So that is what we see over here. So in the parallel transmission, you can see that there are 8 bits is being shown here. These 8 bits are parallelly moved at a time t from sender to receiver. That means from here, at what time it transmit, all the bit will be equally reaching the receiver also in the same interval of a times. So 8 bits are sent together, and we will see that 8 bits are arriving here. So this is nothing but a parallel transmissions. So when we try to see the parallel transmissions, this is a very faster form of a transmission, because all the bits are moved at a one instance from the sender to this receiver. Now the disadvantage of this parallel transmission is that since it is a 8-bit, it is easy to represent. Suppose there is 1,000 bit, so how will you represent? So that creates the communications channel. This is a communication channels. So the communication channel will result into congestions. So that is another problem. Not only that one, there will be a cost, and the cost of the channel will also increase, because you need that number of channel for processing the higher amount of bits. Now if you see on the other side, you can see there is a device master and a slave. So here the data are transmitted, and from the 8-bit data, LSB bit is there, MSB bit is there, data 0 to data 7, and here there is a handshaking is there. Handshaking is nothing but a clear to send. Once it is a clear to send, this master will be writing this one for the device, and when this device is about to read, then this R will be activated. So this is a handshaking. So based on the handshaking, this communication take place. Normally in the handshaking is like this one. Initially a request from the master to slave, and the slave, if it is free, then it will send another handshake as CLR, which is a clear to send. After that, master getting the CLR, it will send a data. Once that data and everything is received, that is the data is received, this will send ACK, that is acknowledgement. So that is known as a handshaking. That's how these parallel communications also follow. So data lines may be a unidirectional or a bidirectional, and that is what we say in the parallel. Width of the data bus is usually 8-bit. Here it is as per the figure. The full bytes of a data is transferred on each read and write clock cycles. As per the clock, the read and write will be communicating. So, and the chip select CS allows the multiple device to share the bus. So based on the CS or chip select will allow the trigger signal to make the communications to functions from the device 1 to device 2. Now when we see the next one, serial interface, this is a serial interface. So in the serial transmissions, one bit follows the another bit. So it is a one bit communications channel between the sender and the receiver. So even if there are n bits will be following in this single line channel. So that is how you find a difference between the serial transmission or a serial interface between serial and transmission and parallel transmissions. Now in this case, if you see that sender is sending a signal, assume that it is being shown here. So this representation is nothing but a parallel representation. So you need a parallel to serial converter. So after that, the serial signal will be communicating over the channel. At the receiver end, you need another serial to parallel converter so that it will be received at the receiver end. So this is nothing but the protocols that it follows between the sender and receiver. So we need only one wire to communicate. So for the N transmission also we need a one bit form of a transmission. So that is the advantage is in this case is that our channel bandwidth will be less, but the cost is that it has a slow form of a communications, because since it is a 1 by 1 bit transmission is taking place, so the transmission rate will be slow as compared to the parallel form of a communications. However, the transmission reduce the cost of the transmission cost. So this is how the serial interface take place. You can see this one, a control line or a clock signal. Once it is received, data is sent from here to here, and that is either the two devices will communicate based on the clock, data transmitting, data receiving. So data in, data out is taking place between the two devices. Now we will see the two components, another components with respect to the serial transmission, that is asynchronous transmissions, synchronous transmissions, and isochronous transmissions. Asynchronous means the one which is not synchronous, so that is known as asynchronous. So in this mode of a transmissions is that when a character is sent, it is transmitted at a different intervals. Now before understanding this asynchronous, let us see how the asynchronous bit is being represented. Any asynchronous bit will be having a data bit surrounded with the header and the tailer. So this is the header is a start bit, tail is nothing but a stop bit. So here you can see a 10-bit transmissions. So sometime you will see there will be 11-bit also, that is a parity bit, but here we will not take into account that parity. Let us think that data bit, that is a 8-bit here, sender bit, start bit and stop bit, and the direction of flow is from the sender to receiver is like this. So this asynchronous form of a transmission is simple to look, but it is expensive. Now in this form of transmissions, what the sender will be doing, this we let us treat like a packet. So it will send or you can think like a group of bits. So there is a 10 bits group is there. So you can see there is a 10 bits, 10 bits, 10 bits, 10 bits like this one. So sender will be sending a 10-bit group from one point to another, and between this one you can find a different time frame or a time gap will be there, the gap between the data unit. This is a data unit, so this between this one there will be different variation in the timing. So that is put under the case of the asynchronous mode. So you can see that this system send one character at for a time with a delay time between the data. So between the data you will be finding a delay. It is also called as a start and stop protocols. So when this data is being sent, so the next data, if it has to process, the previous data stop bit will be there and the next data start will be there. Stop and start is being distinguished with respect to the bits configurations. So 0 bit is for the start and 1 bit is for the stop. So that's how this bit is being represented. In the asynchronous transmissions, that is what start is bit is a 0 and the stop is 1 bit, and there may be a gap between the each byte. So this is this collection of a bit is a byte. Asynchronous means asynchronous at the byte levels. So there is a byte is that this is 1 byte to byte. Between the, these two there will be no proper synchronizations. So this will be taking as a 2 millisecond. So this may take a 1 millisecond. This may take a 5 millisecond. Like that, the things will be moving. So that is what the asynchronous. So in the asynchronous, you will find that there will be a slower transmission process that will be taking place. Now we'll see the synchronous transmissions. In the synchronous transmission, you can try to see that there is a sender, there is a receiver, and you can see that in the synchronous transmission we transmit in the form of a frame. Frame is a collections of bits. So that is what we see in the case of the synchronous transmission, or a block of a character is marked with the synchronizations characters, and that is what we termed as a frame. Now here you see this one, there is a data is of a first character, the 8-bit data is there. There is another data of a 8-bit, and once these along with these two data character, there is another synchronous signal is sent. After that, the next of data will be sending. So this is showing that how the data is being synchronized in a proper order, and this collection of bits is being put under the under the one stream, or the direction of flow is being shown like this one, and you will find that all the bits are serial. It is moving from one end to the another end. Normally one send normally sends 1 or 2 synchronous bit to synchronize the systems and then the data is sent without interruptions. In a synchronous transmission, we send bit one after another without start and or a stop, just like in the asynchronous case, or a gap. It is the responsibility of the receiver to group the bits. So how the receiver will know that which is the bit which is coming in this forms is having informations. So basically whenever there is a gap is there, that particular portion we treat as a term as an ideal. When there is an ideal level, suppose in a particular bit particular point you are not finding any characters or any bits because of the information is not there. So in that case that becomes an ideal. So a special sequence zeros or a ones is being added to added in that particular scenario. Or in the synchronous transmissions, what we normally do is that one we try to create a data. Along with the data, if there is a ideal bits are there, then in that case we try to create either a zeros or ones, and on the front side we put another synchronous content, which is nothing but a F is standing for a flag. So we will be having a flag as 1, then we will be having a I as a idle data, then we will be D as a data which we need to process. After that, if the next information starts, then again we will be putting F as a flag, then I as a idle if it is existing. Otherwise the data will be there. So the flag will be there always to identify the start of a block boundaries. Thereby the clock will be accordingly trying to click. So based on the clock signal, these datas are moving. So if you are taking this one, assume that there is a flag here, then after that there is another flag we can create here. So like that one, or we try to create a one flag here, then for this one there is another flag is there. So this complete one frame it goes. After this one, the next frame when it starts, before the starting there should be a flag. So the distinguish the block can be distinguished with respect to each other with using a flag. That is how the synchronous works. So in the synchronous communications allows the faster data transfer rate than the asynchronous mode, because additional bit to marks the beginning and end of the each of the data bytes are not required. So that's how it can able to process much faster. Only we can use a flag. Isochronous. Isochronous is nothing but the hybrid of the synchronous as well as the asynchronous mode of a transmissions. So basically it transfer the data from a sender to the receiver within a certain time frames. Now isochronous it consider the asynchronous form of a communications. Basically in the gap, the gap which you can try to see in the asynchronous case, the gap was there. But here what we try to do is that here we try to create the synchronous. In this form of communications, the actual transmissions taking place between the two bits is that synchronous process is basically taking place in this gap. So there will be a proper synchronizations taking place here, whereas asynchronous is being taking place within this particular data streams. So this particular process in which this particular data stands, this is been broken into a random intervals. So this is asynchronous, this is a synchronous. So this form of a communication is known as a isochronous. Now here if you see in this time of transmission, the source and the target systems are synchronized. Each transmission and receiver transmission methods, a asynchronous start bit and stop bit, the transmitter and receivers are not separated. So if this is a start and stop bit, so what is this one? This is asynchronous. But here we are maintaining a gap in a synchronous mode. So this becomes a asynchronous, this is become a synchronous. So this is known as asynchronous form of isochronous form of a communications. In this type of a communications, the source and the target systems are characterized. Each transmission and the receiving transmissions includes a asynchronous start bit and a stop bit. And isochronous communications, the clock that guides the transmitter and the receivers are not separated in this form. Okay, this one, the clocks that guides the transmitters and receivers are not separated. Why it is not separated? Because this particular frame or we term this particular the asynchronous bits, that is 10 bits. These 10 bits, each 10 bits is being properly synchronized. So that's why the sender to the receiver clock should be properly synchronized form of a communication should take place. The maximum time interval is not prefixed between which a frame of bytes transmitted between which a frame of byte transmit, that is, it can be variable. That means if you are having this is a fixed, but this you can change in such a way that whatever changes you are doing, that should be also reflects in the each gap. So that is what we term in the form of a synchronous form of a transmission plus asynchronous form of a transmission, and when it is hybrid together, it becomes a isochronous form of a transmission. So by this we complete the introductions part of the module 1 first sections with respect to the computer communications, and I believe that this has given an idea about the basics of the computer communications introductions. Thank you.